Let's talk about the MMap storage engine. We call it MMap v1. It's the original storage engine of MongoDB, and it uses the mmap system call under the covers in order to implement storage management. Let's look at what the mmap system call looks like. It's right here. If you do on any Unix machine, if you man mmap, you'll see that it talks about allocating memory or mapping files or devices into memory. Causes the pages starting at address and continuing for at most length bytes to be mapped from the object described by the file descriptor at an offset. So what does that really practically mean? Well, MongoDB needs a place to put documents, and it puts the documents inside files. And to do that, it initially allocates, let's say, a large file. Let's say it allocates a 100 gigabyte file on disk. So we wind up with a 100 gigabyte file on disk right here. And this disk may or may not be physically contiguous on the actual disk because there are some algorithms that occur beneath that layer that control the actual allocation of space in a disk. But from our standpoint, it's a 100 gigabyte contiguous file. If MongoDB calls the mmap system call, it can map this file, this 100 gigabyte file, into 100 gigabytes of virtual memory. Now to do that, of course, we need to be on a 64-bit computer, because you could never get 100 gigabytes of virtual memory space on a 32-bit computer. You'd be limited to 2 or 4 gigabytes. And these are all page-sized, so pages on an operating system are either 4K or 16K large, so there's a lot of them that I'm not showing here. And the operating system is going to decide what can fit in memory. So if the actual physical memory of the box is, let's say, 32 gigabytes, then if I go to access one of the pages in this memory space, it may or may not be in memory at any given time. The operating system decides which of these pages are going to be in memory. I'll just say the green ones are in memory. And so when you go to read a document, if it hits a page that's in memory, then you get it. And if it hits a page that's not in memory, let's say this page, then the operating system has to bring it from disk. This is on disk here. It has to bring it from disk into memory before you can access it. And that's the basics of where the mmap storage engine works. Now, the mmap storage engine offers collection level concurrency, or we sometimes call it collection level locking. And each collection inside MongoDB is its own file if you look in data/db. So what that means is that if you have two different operations going on at the same time and they are in the same collection, one's going to have to wait for the other one if they're a write, because it's a multiple reader, single writer lock that it takes. So only one write can happen at a time to a particular collection. But if they're different collections, then it could happen simultaneously. In addition, the way the storage engine works, mmap v1, we allow in-place updates of data. So if a document is sitting here in this little page right here, and you do an update to it, then we'll try to update it right in place. And if we can't update it, then what we'll do is we'll mark it as a whole, and then we'll move it somewhere else where there is more space. So maybe we'll move it over here or something, and then we'll update it over there. In order to make it more likely that we can update a document in place without having to move it, we use power of two sizes when we allocate the initial storage for a document. What that means is that if you try to create a 3-byte document, you're going to get 4 bytes. If you try to create a 7-byte document, you're going to get 8 bytes. A 19-byte document, you're going to get 32 bytes. And this way, it's more likely that you can grow the document a little bit, and that space that opens up, that we can reuse it more easily. So that's the mmap storage engine. And you'll notice that since the operating system is what makes a decision about what is in memory versus what is in disk, we can't really do much in terms of controlling that. The operating system is pretty smart about managing memory, so it's usually not a bad algorithm, but the database doesn't get to decide or contribute its opinion about what winds up in physical memory versus what winds up on disk. And if you're curious about the way virtual memory works in general, just Google virtual memory and storage systems, and it's the same algorithms that are used to manage memory inside the operating system for all programs. Okay, now it's time for a quiz. Which of the following statements about the mmap v1 storage engine are true? Check all that apply. The first is that mmap offers document level locking. The second is that mmap automatically allocates power of two sized documents when new documents are inserted. The third is that mmap is built on top of the mmap system call that maps files into memory. And the final one is that MongoDB manages the memory used by each map file, deciding which parts to swap to disk. So check the ones that you think are correct.